Hello everybody, so this is a follow-up video of my last video, the Reorder List. In my previous video, I solved this question with overwhelmed time complexity and overwhelmed space complexity. But I read the editorial and actually I noticed that I can solve it with overwhelmed time complexity and over one space complexity. So I will introduce how I can do it in this video. So I skip the clarification or something like that, and I will, you know, immediately go into the explanation. So in this question, I'm given the linked list, and my task is to reorder this linked list in this way. So I don't have to return anything, but I just have to, you know, reorder the list in this way. So firstly, I take the first one, then the last one, and then I take the first to, second to first one, then second to last, and third to first, third to last, and then in this order. So in my previous video, I created a list of the nodes, like the list which includes node 1, node 2, node 3, node 4, node 5. Then I use the 2 pointers from the leftmost index and the rightmost index, and I pick the node alternatively from the list, and then created a new linked list. But obviously this takes over space complexity, but because I need the list for that. So here I introduce another approach. So once I get this, firstly, I have to split the array into linked list into two. The first half and second half. Then so I have now this and this. So now what I should do next is so it's the second one. Like this. So with that, now I have this one. 6, 5, and then 4. Then I can say I should merge. Oh, so when I have 6, it should be 6. Yeah. So then I will merge these two linked lists alternatively. So it should be 1, 6, 2, 5, 4, 3. 1, 6, 2, 5, 3, 4. So one node from the first one, then second from the second one, third from the first one, in that kind of alternative way. Yep. So this is the approach I can take. Okay, so for the first one, splitting, I have two ways to realize this. So the first approach is count the number of nodes, then I split it. I split the given linked list according to the number divided by 2. Yeah. And one more thing I try to take care is if there's maybe odd number of nodes, how should I split? Like if I have 7 nodes, should it be split into 4 and 3 or 3 and 4? So, and I can say actually it doesn't matter which. Yeah. In which way? So, because in the end, the middle one, the center one, should be in the tail of either. Maybe for I mean the center node should be the end of the 4-node linked list. So in either way, it should be in the end as expected. Okay. That being said, yeah, I start implementation. Oh, so what I wanted to say is when I split um, the linked list into two, number one approach is count the number. Number two is use the pass pointer and throw pointer, 2 pointers. Okay, so I will tell how I can do it later. So let me implement. This is step one. So step two, so it's the reverse the second list. So this should return the reverse head. Okay. Then I should merge. So this internally merges the linked list, and head one's first node should point to the, reverse head two's first node, and then nodes are connected alternatively. Okay. Good. Now let me start with the split method implementation. So as I said, I use the 2 pointers, like so I point to the first pointer and the throw pointer into the first node. Then while this first node is on the node, I kept moving. Yeah. And maybe I move throw dot next to throw dot next to. Okay. But I have to take care when I move first twice. Maybe on the second one, I cannot. So in that case, what should I do? So let's say there is only two nodes. In this case, I try to move first twice. The first time, yes. No. Let's say this one. So first is moved twice, yes. And second is moved twice. Only once. Yeah. Sorry. So here, yes, it's okay. But in this case, I don't have to move it anymore. Actually, now throw is at the second half head. So I can say first is not Only in this case, I move it. In this way, I can move it twice. And move the throw once. Yeah, and that's it. So in this way, if there, let's think one more case. In this case, past dot next is not known, so this is moved twice, and throw is moved once. And after that, I cannot move it anymore, and throw is now pointing to the latter half's head, like 2, 3. Let's say I have one more. In this case, past is moved twice, this and this, then throw is moved once. Yep. Still, this throw is pointing to the head of the second wrist. But one thing I notice is here I have to check also first is not num and first dot next is not num. Yep. Okay. So now I should return throw. And I have to split throw dot previous. So a bit annoying. So okay. We should do. Okay, so let me implement this later. Let me start with reversing. So here, this one, I can use 2 pointers, sliding. So what I should do is previous here and current is pointing to this one first. So current dot next is prev. I do it. Then now what happens is one is pointing to num. Okay. Then I shift previous and current, but I have to take care that current dot next is not next anymore. So maybe I can name it temp. Now current dot next is prev and current prev current equal to current and temp. Okay. And in the end, let's see. So I did it, and then when I'm at here, temp is current dot next, so temp is here. Then current dot next is prev, yes, and prev current is moved to here. And still current is not num, so temp is now pointing to num, and current dot next is prev, so this part is reversed. Then after that, it moved in this way. So what I should return is prev pointer. Yeah. Next, merge method. So if either of them is not num, in this case, I choose current 2. So no, sorry, it's current. Yeah. Hmm? No, I choose current 2. So current, when I merge it, I should return the head one. This is the head. In the end, I actually return this. Now what I can do is, so head 1, head 2 is okay. And return, also I have to keep track of the current pointer in the returned, merged list. So now I choose current 2. Then, just in case, I reset current to the next. No, I can't do that. Yeah, I just have to do it. Then, if current 2 is none, I move the current one. I choose the current one. Oh, and I also have to move this and this. Okay, so here I do the similar thing. I move the current one pointer. Otherwise, I have to choose current one or current 2, alternatively. Oh, so I can use this flag. Here, according to this, I should choose whichever. Choose current one. In this case, I do this. Otherwise, I move this. And move current 2. Okay. So what should I do next? So also I have to flip this. Okay, so this is it. Yeah. Actually, yeah, it's okay. Yeah. So now I come back to split method, maybe. Slow prev, fast prev. Yeah, I moved 2 pointers. So what I've noticed is that I moved faster to RE and throw pointer doesn't have the. Oh, I'd try to do. The problem here was that, yeah, I can return throw pointer, but throw pointer is pointed by previous one. That's the problem. But I think it's okay for here because in merge method, I took care. I just have to take care that the end node in the previous, faster one is not pointing to anything in the end. So what I should do is here, according to what is, pointed. Oh, it's been 20 minutes. Well, so I want to remove this one, this pointing. So what I can do is I always have to make sure that current one, I mean, this one is not pointing to anything. So what I can do here is in the end, current.next should point to none. Okay, so done. So let me submit my code. I see. So I just returned head 2. And I can use head as it is. Okay, so it doesn't work. So let me debug it. Now head 1 is pointing to head 1, head 2, head 3, and actually head 4, node 4, and that's it. And the router one is pointing node from node 3 to 4. Yep, as expected. 1, 2, 3, 4, 5, but the router one is 3, 4, 5. Okay, good. For next one, serve those reverse. So now router one is pointing from 4 to 3. Yes. 5 to 4 to 3. Yes. Completely as expected. So I merged them. So read is head 1. I actually didn't return anything. I just can do it. Yeah. Choose current one is true. This is okay. Current 2 is none. In this case, I choose current 1. This is okay. If choose current 1, I choose current 1. Oh, okay. Yeah. This is okay. Current 1 is current 1 dot next. Yeah, looks good. Let me just delete this one and try it. No, it doesn't make any sense. Any difference. So I think the problem here is current one keeps going. Maybe. No. Here. So if in this case, I should choose current 2. So it's completely weird what I'm doing. Merge method is completely messed up. Let's think of this case. In this case, current one is here. Current 2 is here. And current is pointing to node 1. And actually 2, 3. And actually, this is pointing to 4 and then 5. Yeah. Okay, so let me just change this implementation. Right? I completely split the linked list. I don't use 2 pointers here. So num is 0. Now I got the number. The next thing I should do is split it. So divide by 2. If there is a 5, 0, 5, I want 3 in the first half. Maybe I can do it in this way. Yep. So in this way, if there are 2 nodes, it should be 1. If there's 3 nodes, it should be 2. Okay. Good. So, and let's say I want 1 node and I'm here. In that case, firstly, without any move, there is 1 node. So, and I want here. So how many times should I move to move the pointer? In this case, there should be 2 nodes in the first half, so I should move it twice. Yes. Yeah. If I want 2 nodes in the first half, I should move twice. So exactly this half num times, I should move the pointer. Then I return current. Yeah. Let me quickly check what happens now. So now head is yes, only pointing to 3 nodes, or 4 nodes. And as I said, I have to split. So okay, I have to move -1. Then I should do current.next is none, and I return current.next. Wait. Current.next should be none. Yeah. No. Yeah, true. Okay, so now it looks good. So the last thing I have to do is update the merge method. So now it looks like this. If current 1 is none or current 2 is not none, I kept moving. But I can say I just have to check current 1 is not none, because now always current 1 has exactly half or 1 more than no headed to linked rest. So if current 1 is not none, I keep doing. But if current 1 is none, it means that that's the end. Yeah. And I can completely forget this one. I can say this one here. So with the frog, if I should choose current one, yes, I choose it. Oh, the problem is current is already pointing to current one. I think that's the problem. So probably I should use a pseudo head here. In this way, current is pointing to the pseudo head, and then I'm choosing node 1 and node 2, node 3, node 4 alternative array. So, yep, now I can do it. Okay. Let me try again. Hmm. So choose current one is flipped every time. Hmm. So let me print out head 2. Oh, since like merge method is not called, maybe? Self.merge. Then where is this merge method? Okay, but anyway, I have some progress here. So head one is always, current one is always, head one is always longer linked list rather than compared with 2. So while current one, head 1, current 2, head 2, I see, this isn't true, obviously. So even if, current 1 is not num, current 2 can be num. So what should I do? And if current 1 is num, I still have to choose current 2. So I can do something like this. Yeah. Okay, good. And then submit. Okay, accepted. Great. So we can wrap up. So I solved the question, Reorder List, with all one space complexity approach here. So basically, I firstly split the array into 2 linked lists. Then I reverse the second list. Then I merge 2 lists alternatively. So I was a bit, you know, uh, stuck in the implementation of a split. I shouldn't have used the throw pointer first pointers. I just have to count the number of nodes. Yeah, that was the best way. And when I merge the 2 lists alternatively, yeah, I was a bit confused about this while loop. So that's something I could do better. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.